Hello and welcome to Food Safety Fridays. Happy New Year, belated Happy New Year to all our food safety friends from all over the world. My name is Simon Timperley from the International Food Safety and Quality Network. Today's special guest is Maria Sandoval from Trace Analytics LLC. And today we're going to be talking about LPCs, how to troubleshoot particle contamination in compressed air. So welcome Maria. Nice to have you back.
Good morning. How are you? Well, afternoon in your case.
Yeah, it's 3 p.m. And whereabouts are you, Maria?
So I'm in Austin, Texas. Trace Analytics is located in the Hill Country in Central Texas. And it's weird, but it feels like we're having spring in the middle of winter. So it's kind of nice.
Yeah, very nice. And so what time is it? Are you on
It
Central?
is 9 a.m. Central Standard Time.
9 a.m. Well, wherever you are in the world, you've joined us today and we're delighted that you have. So please tell us in the sidebar, as always our custom, where you're joining from and good morning, good afternoon, good evening. We're going to play the video right now and we'll be back for Maria's presentation shortly. Okay. Okay, I'll be back for the Q&A later, but for now, I'll hand you over to Maria.
Great. Thank you so much, Simon. So today what we're going to be talking about is troubleshooting particle contamination in compressed air systems. And we're going to be discussing one particular technique, and that's the use of laser particle counters. And in a little bit, we can get over the different methodologies that are available and that are also acceptable in different standards, gravimetry, microscopy, electron scanning. But this particular talk is focused on laser particle counters. So like Simon said, my name is Maria Sandoval. I'm the lab director here at Trace Analytics. We are located in the Hill Country in Central Texas. We've been around and we've been doing compressed air testing since 1989. We started primarily in breathing air and then we moved on into manufacturing. And now we're helping individuals like you in the food and beverage facilities by providing ISO 17025 accredited test methods that are suitable for testing to ISO 8573, ISO 14644, ISO 14698, and any of the custom specifications that your quality departments come up with. I do recognize that a lot of people have their own specifications, and I think it's important to note that a lot of those specifications derive from these ISO standards. There are a handful of us here at Trace Analytics that are members and contributors to some of the food and beverage committees that drive your facilities quality standards. One of them is ISO 8573. Currently, I am rewriting Part 7, which is microbial contaminant testing. We also have Part 5, which will be updated hopefully by the end of 2023. We have people who are on ISBT, which is the International Beverage Technologists Committee, specifically in gases. And we have 3A Sanitary Standards Committee members as well. We operate on a few acres of land here, and a part of that is state-of-the-art equipment that allows us to do these analyses for your particular testing. And we're able to work with people all around the world. So that is why it's a boon to have Simon offer us this opportunity to get to talk to you guys on an international platform. And if there's ever anything that we can do, questions we can answer, or any test kits that you guys have questions about or would like to utilize in your facility, please let us know. My email address is at the bottom as well as my phone number. So I think it's important to note that every breath you take, you're inhaling about 200 million dirt particles. And it is something that you probably don't think about on a daily basis. It's pretty funny though, because we are in the midst of a pandemic. So a lot of people are cognizant of what they are breathing, but not many people can correlate what they're breathing to what is actually being in direct contact when they're utilizing the air that they're breathing, going through an intake of their compressor system and then being filtered onto their point of use. So when we talk about contaminated air, we're talking about the ambient air that is collected near your intake. We're talking about the air that is being processed through your compressor system. What you see there in the middle is media. So you have your filtration, you have your dryers, your molecular sieves, your coalescing filters. You have all of this system that's in between the intake and your point of use. And we need to discuss what happens when you have particulate contamination. Where does it come from? What can you do to be more mindful about avoiding contamination issues with particulates? What does your spec limit require of you? One thing that I have noticed is that we have a lot of new customers who are requiring validations and qualifications of their systems because some of the standards like SQF have now required monitoring and testing of compressed air. And so what you guys are starting to do is validate the systems before you put them in use. And so you're asking questions like, how do I test my air? How do I test for particulates? There are other particles, water, oil, gases, microbial. Today we're talking about solid particulates and how you test those. Once you do determine that you may or may not have a contamination problem or you're in the midst of a validation. And then the piece that's most important is, how do you know your test methods are compliant? That's one of the most important things. Anybody can test anything, right? You can go to an off-the-shelf system, but you need to be aware of what the requirements are when you are testing to a particular specification. So right now, who defines and guides your food and beverage industry are people who are in committees like the FDA, SQF, FSSC, for some of you international food, IFS, BRC if you're in Europe. But one of the driving factors here is that ISO standards are the guidelines. They're the foundations to what a lot of these recognized standards are standing on. So if you have a chance to purchase ISO 8573, or your quality department does, I would say, look through the standards and see what they're asking and see how relatable those test methods are to the qualifications and the specifications that you're being asked of your quality system. But these are the entities that are primarily running the definitions and guidelines for the quality of air and food and beverage. So what's next? This talk is talking about troubleshooting with laser particle counters. So one of the common questions that we get from customers is, our quality department has told us that during one of their audits or during one of their tests, we have reached an alert or an alarm level. And so the engineers are then called, because the quality department doesn't typically mediate the problem. They call a technician, or they call an engineer to mediate the problem. And so the next question is, what is this person going to do once you realize that you have an alert or an alarm level that's been reached with particulate contamination? And the truth is, you need to slow down your thought process and think about the common sources of contamination. And some of the common sources of contamination are piping. I got a call one time from a customer in New York, and they were saying, well, we just switched our compressor to an oil-free compressor, so it should be fine. And it's like, well, you didn't switch the piping out, and the piping was 80 years old, and it was also iron piping. And we'll go over the materials being very, very pertinent to having particulate contamination. The other issues is that, are you making poor choices when it comes to fittings and unions? A lot of people don't understand how soft brass is, or if you're connecting brass to stainless steel, what can happen during that union, stripping threads. A lot of that microscopic particulates happen when you're stripping a thread, and that can get sucked in to your piping system. And that goes into connecting metals of different hardness as well. The other thing is valves. We have there's an interesting thought about ball valves. I don't know if you guys ever really considered what happens when you turn a ball valve. But there is the touching of the ball to the base of the piping system, to the valve. And so when you open and close it, you're releasing these little particulates. And so you want to be mindful of the materials you're using if you choose to use a ball valve in that way. Also, improperly applying tapes, Teflon tapes, dope, solder, anything like that, you need to be mindful of. These particulates are microscopic. You're not going to see them. And it's hard to believe, once you put a laser particle counter on your point of use, to imagine that something could give you such high numbers. But these are 0.1 micrometer particles, 0.3, 0.5 micrometer particles. So every step that you make when it comes to dealing with your pipings and your joints all matter. And lastly, our O-rings. Excuse me. Our O-rings. And so you can have different materials of O-rings. You can have wear of O-rings. Some O-rings have lubricants on them. So you need to be thoughtful when you're purchasing O-rings, or when you have an engineer who's ready to do maintenance, preventative maintenance. You need to remember that you have O-rings in a lot of these fittings and unions. So we have this material preferences for better air samples. This was taken off of our website. And what you see here, and this is in conjunction with the particulate sources, is a best material to worst material. And I'll let you take a screenshot of this because it's a really great tool when you're thinking about troubleshooting. Well, my piping system is okay over here, but it's not okay over here. But I see a branch that is made of aluminum over here at this point of use, but the newer branch that we've created is made out of stainless steel. So maybe those two differing things could be the driving factor of some of your particulate contamination. As well as welded seal types, nothing beats having a welded um, joint. It's definitely better than threaded. There's no risk of having two differing hardness materials threaded together if that exists. Same with O-rings. There's no risk of having degradation of O-rings. Same with sealants and valvings. You want to be mindful of the ball valves like we talked about earlier. Now, a lot of this chart was built on laser particle counter observations and customer experiences. And while some of it is pertinent only to particulates, it's also important to remember that a lot of it can be applicable to water and oil as well. So you have found out that you have particulate contamination in your system, in your point of use. And so typically what we see, and this is just a typical representation of two ISO standard purity classes. On the left, you'll see ISO 8573 Part 1. There are 9 parts in 8573, all talk about different contaminants. Part 1 is discussing purity classes. So on the left of the left chart, you'll see bin sizes that start with 0.1 micrometer and they go up to greater than 5 micrometer. And then you also have classes 0 to X. So if you are testing to a class 2 and you fail because you have 500,000 particles of 0.1, then you know you need to select a troubleshooting piece of equipment that can determine whether or not your numbers are going up or down based on the maintenance that you're about to or that you have performed. And that is the number one issue here. You need to have some sort of real-time knowledge while you're doing this troubleshooting, and that is the power of laser particle counters. And we'll get into that a little bit later. So now you know, okay, well, I'm at 501,000 particles in the first bin, which is 0.1 to 0.5. So now I kind of have an idea of how low. I'm an engineer. Now I have an idea of what I need to see when I'm doing my maintenance and testing again and again. And then the next SOP or standard rather, sorry, is 14644. And so this is one that is a little bit different. This is primarily driven by ambient air classes. However, this 14644 talks about controlled environments. So 14644 discusses controlled environments and air cleanliness. ISO 8573 talks about purity classes of compressed air. So if you are using 14644, just know the values here are a guideline for ambient air that have been utilized for your compressed air system. And that means that this is a controlled environment. So your values are going to be lower. That's why you see these classes look so different. So you've decided that you now know kind of how you need to get lower. You realize the bin size that you need to remediate. You realize that you need to focus on a certain particulate size. And now it's time for you to determine what type of equipment you can use to reach that goal. So for some of the purity classes, and if we go back, you can see down here, ISO 6 is by mass, and over here, 14644, grade 7s and 8s. These are all microscopies. These are able to be done on filter membranes, which this arrow is pointing to here. This is one of our representative kits here at Trace Analytics. We use NIST traceable calibrated flow meters. And what you can see is that this filter can achieve the compliant methodology required by 8573 for classes 6 and up if you want to do gravimetry, which is using weight, or you can do microscopy for classes 3 through 5, and that bends 0.5 microns and up. But if you have a bin size that is not conducive to either one of those methods, then the next method that you have to use is a laser particle counter. And so the laser particle counter, you can rent from Trace Analytics. It's typical that it's kind of cost prohibitive for many facilities to just purchase because you do have to have it calibrated yearly. You're required to adhere to a lot of these specifications that are required through ISO 8573 or 14644. And so here, when you're looking at the handheld Cetra on the left, it's about the size of a handheld vacuum cleaner. It ranges from a size of 0.3 to 25 micrometers. Typically, when you look at the channel ends at 10, but the 10 channel goes from 10 to 25. The benchtop AeroTrack is a little bit bigger. It's more robust. However, it's more, it can go lower with its detection, and it can go to 0.1 micrometer, which is a requirement of class 1 and class 0. So when we're discussing using a laser particle counter to remediate and to look at and to troubleshoot here particulate contamination at your point of use, we need to be mindful of the pros and cons of using certain pieces of equipment. So the pros are definitely you can do direct measurement. You can get the values right there. Now, one of the cons is it is not a accredited report that has been generated by an ISO 17025 laboratory. What you're getting is raw data from a niche traceable equipment, but it hasn't been looked at, analyzed, and converted by a ISO 17025 accredited laboratory. So that is why you can submit your data to third-party laboratories like Trace Analytics, and we can get that done for you. They are accurate. They are niche traceable. They can, so AeroTrack on the far left can go down to 0.1 micrometer. And if you wish, you can also select the niche traceable calibration documents for your auditing purposes. So that's one thing that's important in your controlled environments for food and beverage is being able to have an auditor see your traceability when you were doing measurements. You weren't just doing a measurement with an Amazon purchased air counter. You were doing it with a NIST traceable scientific piece of equipment. So that is how these types of equipment differ. Again, the cons, and we'll talk about this in a moment, is short sampling times, and you'll see that in a second. And additionally, it's kind of bulky. The one on the far left is bulky. And why is that? Well, because you're going down to 0.1, so you need a heftier laser. But it comes with a built-in printer, which is pretty nice. So when you are going to, you're going into the field, these are some select in-field troubleshooting tactics that you can do with your LPC. So what you can do, and what is always important, is to cycle purge your system before you test. But if you know that the person who took your test before hadn't done that, you can do a before test with your LPC. Let's say we're going to do it at the first purge at the end of the valve branch. You can hook up your LPC here, purge it, take your sample, and then allow it to purge for 5 to 20 minutes, and then take excuse me, then take another sample. At that rate, you should be seeing a difference in number, and that's because whatever is trapped in here, if you're not purging at the end of the day and emptying the air, and many people aren't because they can't, gives you an idea of the importance of purging the line. So that is one benefit of being able to do a before test and an after test and having that data in front of you. And then saying, well, maybe this purge area down here that's at the end of the branch because it's a mile further away from my gas source needs to be purged for 30 minutes and not 20 minutes. And you get to see that in real life, in real time. The next kind of infield thing I wanted to talk about was something that we saw with a customer. And I thought this was crazy. I never even considered that somebody would install a coalescing air filter parallel to the ground. What does that mean? So that means that this lower drain was not up and down, it was parallel to the ground. So the water was able to seep into the inlet and the outlet. Same with the coalescing filters. So they were getting all these particulates and they couldn't figure out why until an engineer went in with the LPC and they did a before test. And this is what you see here. This is a subset of some of the LPC data that you could get if you export the data directly from the instrument. So you get your calibration date, you get your serial number, how many channels you looked at. The sample duration is in seconds. So this is a 1-minute test at 0.1 CFM. And this is your first channel size is 0.3. And then this is the count. So you can see that these counts are relatively high. They're not failing for class 1, but they're relatively high. And then they fix the filters and they purge their system and then they run the test again. Took them about an hour to do, and then look at the data. So you can see that the particulates went away when they weren't dumping particles into their inlets and outlets. So this is the power of having real-time data. Again, however, you don't have a third-party laboratory giving you an accredited report. And so that's something that you want to keep in the back of your mind. You can always contact us and say, hey, I need my report to have line item 4, and then we will go ahead and do that for you. The other thing that's important is your pressure regulators. This is something that you can see in real time. And it is when you are moving your pressure regulator on and off or adjusting it, because our kits and the LPC do have pressure requirements. We can't put 3,000 PSI onto my laser. You're going to blow the thing apart. So we have a high pressure diffuser. But when you are messing with your point of use regulator, you are going to release particulates, and that is because of the pressure differential that is occurring. So you're going to push oils and particulates that are trapped in that regulator. And it happens momentarily, it happens very quickly, but it is something that happens and can skew your numbers, which is important to have a stabilizer for your regulator if you can afford it, or to make sure that you set your pressure valve, you purge the line, and then you take a sample, and you do it in that order. So we talked a little bit already about on-site real-time particle data, but this is a screenshot of what it looks like if you do get a laser particle. You have the ability to look at the differential total in cubic meters. So a lot, if not all, of the LPs of the particle contamination specifications must be reported in cubic meter. So it's always important then that you translate your data into something that you can compare apples to apples. So in this case, you can translate it to cubic meters on the screen. And so you can see the channels here, and then you can see, oh, okay, I have 9 million particles in this size range, but I'm looking at the differential total, which shows you the counts which are at the least of that size and up, but not including the next. So it would be 0.3 to 0.4999999. This one is a cumulative total. So basically it's this size and up, this size and up, this size and up, and so on. You can also change the location name. You can change your sample hold time, your sample run time, and all of these are important when I show you the power of extrapolation and the power of sample time runs. So I want to be mindful that you guys understand what these channels mean. So this is a screenshot of the channels from, in this case, a Cetra LPC. Many of the other manufacturers that make LPCs have similar channels. Some of these can be changed if you need to. Typically, the first channel and the last channel can't be changed. But what a channel implies is a bin. And so for Cetra channel 0.3, it encumbers 0.3 to 0.49999. For 0.5, it's 0.5 to 0.99999, and so on and so forth. For the Cetra, 10 is the largest bin size, and it is greater than or equal to 10 and stops at 25. It has to stop somewhere. And in this case, for this particular model, it stops at 25 micrometers. So when you're talking about using an LPC, you want to take into some considerations about making sure you're doing water and oil testing in tandem. It's super important to be remembering that particles are not typically alone in this. This is not a solo endeavor for them to ruin your life. They're usually with a friend: water, oil, gases, microbial. Purchasing LPCs can be cost prohibitive. So it's always nice to have the luxury to rent a piece of equipment like that, kind of give the onus of the yearly calibration to somebody else. That is something that we can do here at Trace Analytics. We provide the yearly calibration. We provide the documentation to you. We put all that information on your final report. These pieces of equipment are not something that you want to just go outside and turn on. These are very sensitive instruments and are typically used for controlled environments. Because if you go outside, I already told you, you take a breath, you're breathing in 200 million particles at any given time. That's just particles. That's not water. That's not anything else. So you do not want to overload the lasers. You don't want to make them super dirty, because then you will have to encumber the cost of repairs and things like that. So when you are picking an LPC to do your troubleshooting, remember that it is conducive for a controlled environment. If you're not doing if you don't have a controlled environment and you're doing these tests, then maybe gravimetry or microscopy is a better fit for you. And all of those things can be rented and purchased here at Trace. The other important aspect is that particles do not differentiate between liquids and solids in a laser particle counter. They have liquid particle counters. There are different types of particle counters. These are laser particle counters that do not differentiate between liquids and solids. And so sometimes if you have too much moisture in your airline, you can skew the data, which again, we talk about the importance of a controlled environment. You're not typically going to rent this if you have, greater than 250 milligrams per cubic meter of water vapor in your line. So the next thing I want to talk about is the sampling strategy, and that's understanding the flow rates that come with commercial LPCs. So if you look at AeroTrack LPC, you have a default setup of 28.3 liters per minute. That is all that this instrument can do. You cannot lower it, you cannot increase it. That is it. The only thing you can do is adjust the sample time. And when you adjust the sample time, then you adjust the final sample volume that you are taking. So you have to ask yourself, how bad do you want to see 1 cubic meter of air? I would say it's important, but if you encumber the idea that compressed air is so incredibly dynamic, it's changing with pressure. When your compressor turns on, it's changing. If somebody hits a pipe because they're superstitious, your particle numbers are changing. So if you take a 1 minute test and then extrapolate from that 1 minute test, it's okay. It is something that is commonly done. The instrument itself does it for you on the screen. But if you want to err on the side of, I absolutely want to know what is being captured in 1 cubic meter of air, then let's look at the second section, which is, we're at 28.3 liters of air. Then you will need to sample for 35 minutes to capture 1,000 liters of air. And at that point, you will have an idea of, and you will not need to convert your final values that are on your screen. Cetras with the different bin ranges have a lower flow rate, so it's 2.83. So again, you will have to either adjust. 353 minutes to sample is kind of a long time for a laser particle counter, but it's got a battery, it's mobile, it's not an impossible feat to do. But again, if you're comfortable with extrapolating the data, that's more than acceptable to do. Here at Trace, we also have a K810, which is our kit. And these sizes are for microscopy and gravimetry. And then you can sample for 120 minutes and knock out particles, water, and oil all at the same time. And so that's what that's showing you. Again, the LPCs on top are solely particles. You're not doing water, you're not doing oil, you're not doing gases, but the kit at the bottom is doing particles, water, and oil, which is pretty nice. So how can we help you if you're ready to start troubleshooting? Again, you have the 17035, that's not even a thing. 17025, I'm sorry, that's a typo. You have the luxury of having an accredited laboratory who can walk you through what the results mean, how to troubleshoot it. We have a fleet of handheld LPCs here that are available for rent, that are all calibrated, that are all validated before they go out and between customers and yearly. We also provide training. We have an academy that's available online to handle new technicians who are going to be training for you. Maybe you've got a new hire. You want to train a new engineer on how to use the LPCs. We have that all available. We can also combine, which I talked about previously, waters, oil, and other contaminants. And we're available at the typical Monday through Friday. This is what a typical report would look like. You would have your accreditation stamp on the left. You would get your pass fail, your specification limits of particulate numbers, purity class, the bin sizes, and your sample results. So all of that would be available to you on an ISO 17025 accredited report. So basically, the goal of real-time troubleshooting is not just to pass. You're not just trying to check a box. You're trying to remediate the problem in a high quality, to ensure high quality and safety of your point of use. And once that is done, you can close the book on it. You have an accredited certificate of analysis from an accredited laboratory, and you can move on. And that is the power of using a laser particle counter. And if you guys have any questions that you don't think I covered, now's a great time to ask them. I think Simon's going to pop in a second and mediate those questions. But yeah, thank you.
I am indeed. Thanks very much, Maria. I'll just drop the slides. Just bear with me. Okay, we do have some questions. So first one from Brett. Do handheld LPCs and tabletop units both need to be calibrated annually?
Yes, so that is a requirement. That's not just a suggestion. That's not an OEM suggestion. Well, it is an OEM suggestion, but it is a requirement of the ISO 8573 standard. It's a requirement of the 14644 standard, and therefore a requirement of all the accrediting bodies and standards of using measurement equipment like LPCs.
Okay, thank you. Question from Scott. Is there any industry recommendation on how to clean existing compressed air lines that cannot be easily replaced?
So that we usually lean on your OEM for your your air compressor. They are usually they either know the installer of piping, or they have an idea of who can help you with that. I am not currently aware of an industrial standard for cleaning. I am aware of standards that require before and after cleaning testing, but not necessarily on how to clean. I think that is more of an engineering and facilities question that your OEM can definitely help you with. So I would start there.
Okay, I'm not sure you'll be able to answer this. Bernard, they measure also germs. I don't.
I know this question. The answer is yes and no. Some bacteria are smaller than 0.1 micrometers, so they will be missed. Fungi can be huge. Fungi can be 10 micrometers, 25 micrometers. They will be captured as a particle. So yes, however, Bernard, they will never be differentiated on a laser particle counter. They will just come out as a particle count. So if you need to do solid particles and viable particles, then you will have to use two different testing methods. An impaction sampler for microbial and a laser particle counter.
Okay, I'm glad you got that one. Question from Brett. You mentioned the Cetra LPC stops at 25. Is there a level of particulate that could damage an LPC? If so, how can I get an understanding of what my particulate levels may be before exposing the LPC to that risk?
Yeah, so we talked a little bit about the importance of not going outside on a lovely day and pushing on your LPC, because you can damage the lasers that way. There are particulates that are greater than 25 micrometers that can damage the laser face, the mirrors on your particle counter. So what we suggest is doing a pre-test here. We give you a certificate of analysis that says, yes, your point of use qualifies for a laser particle counter. One, so you're not responsible for encumbering the cost of damaging a piece of equipment, but additionally, so you have a good baseline of understanding of the type of contamination and the sizes for your point of use.
Okay, question from Jorge. To verify class 2 compliance, can I use filtering?
So this is where it gets a little hairy. There's two class 2s. There's ISO 8573 class 2, and there's 14644 air cleanliness class 2. So there's that. Can I use filtering? It is definitely a good idea to have a filter at your point of use. So if that is what you mean, I definitely recommend that 100%, especially if you're trying to hit a class 2. I doubt you will be able to do it without some sort of filtration at your point of use.
Okay, question from Carlito. May I know what the best air compressor food grade oil is for food safety?
Well, in my previous talk that Simon has somewhere uploaded, we talk about food grade oil. And so I would recommend that you go read that talk. But there are a number of food grade oils that are important for the differentiation between a non-oil compressor and an oil compressor. So yes, definitely would recommend that talk.
Okay, a rough idea of when that was, and then I can link it in the chat.
Last summer, I think.
Right, okay, I'll have a look for it while you answer the next question, which is from Heather. If you have an outside company that tests your airlines for oil and water, do I need to test for bacteria myself?
Ideally, you could have a lab like us, Trace, can do particles, water, oil, microbial, and gases. So you could do it if you wanted to, but it's always nice to have a third party that's accredited who is going through proficiency testing to issue you a report for your oil, for your water, for your particulates, and for your microbial contamination. If I were an auditor and I saw you doing it yourself, but you weren't an accredited lab, however, you got an accredited report from oil and water, it may look a little bit different. So it's always nice to try to package it all together.
Okay, I did find that previous webinar. I've put a link to that recording in the chat. Don't go and watch it now, just bookmark it for later, and I will include it in the follow-up as well, so you can watch it at your leisure. Question from Trang: Can you inform the acceptable limits for microbiological tests in the food industry?
It's funny, right, Simon? Whenever you say particles, people love microbes.
That's
because
right.
micro is a type of particle. And I think we forget that. These laser particle counters are incredible for on-site troubleshooting, but they won't tell you which of those particles is viable microbiological particle and which is a solid dust or rust particle. There are currently no microbiological limits for ISO 8573. There are microbiological limits for 14698. There are air purity limits for 14644, but not in 8573. So that, and I always say this, poor Simon, he hears it all the time. I feel like I'm just giving up on the question when I say it's a risk-based assessment, but it really is. You have to go to your quality department. They need to assess the risk of that point of use, of the direct contact, indirect contact, how it's being used before anybody can talk about limits.
Okay, brilliant. Thanks. Another question from Carlito. In our practice, we connected an air dryer right after the air compressor. Is this a good practice?
I think that's standard. Yeah.
Okay. Question from Latvia. Oil and water is measured for presence and absence only.
Oil and water is measured for presence. And so oil, no, that's another cool thing. If you were to use one of our kits, oil can be quantified and um, it can be quantified and identified if you're looking at oil vapors. Oil aerosols can be quantified and differentiated between particulates, and water can be measured. Um, yep.
Okay.
And all of these 8573, sorry, Simon, all of these 8573 are all measured analyses coming from our laboratory. So you're getting values. You're not getting detected, not detected. You're getting, hey, we found 25 milligrams per cubic meter of water vapor in your line. We're not, hey, you got water. So that is not compliant to 8573.
Yeah. Clear. Okay. Question from Nikki. Is there ever a time when an LPC wouldn't be recommended?
Yeah, absolutely. If you have pure gases like O2, that is not considered a safe gas to pump through a instrument that has a battery. So in that case, we would recommend using microscopy. We would recommend doing a risk assessment of whether or not that needs to be looked at for certain bin sizes. Additionally, if you are not in a controlled environment, and this goes back to too large of particle sizes, too many particle sizes, that's another time when LPCs wouldn't be recommended.
All right. Question from Brett. Thinking of an earlier question about germs, does the LPC also count oil as a particulate but not differentiate?
So it can, yes, it can count oil as a particulate sometimes. And one thing I didn't include on here, but I think I have in a previous talk with Simon too, is how you determine what a particle size is for a laser particle counter. Um, and all to say, yes, sometimes it can be captured as a particulate, but again, it will not be differentiated. This is not something that it can do. We're trying to get you to troubleshoot your way down from a failure or an alert or alarm system.
Okay. Jorge, the question is whether I can evaluate class 2 according to ISO 8573 using filtration method instead of LPC.
Yeah, absolutely.
You can do. Right. And Javier, for a low risk facility, do I need testing on my airlines?
Yes, absolutely. And to go back to Jorge's question, um, I don't know, can we go back? Is that
Yeah.
possible?
The question about ISO 8573.
Yeah, about class 2 infiltration.
Let me just have a
Uh,
look. Yeah, just let me put that one.
yes. So remember, Jorge, the power of an LPC is having real-time um, troubleshooting capabilities. If you feel like after you use the LPC, you have fixed your system, then yeah, absolutely, you can take the uh, lower cost filtration method and utilize that from then on. So let the LPC be your workhorse, and then let the filtration method be your foundation of testing further.
Okay, I think this is the final question up for now from Colton. Do you have a template for risk assessments?
Yeah, we do. If you visit www.airchecklab.com, we do have a template for risk assessments. If you don't find it, then you can definitely contact me. or contact our sales department or service team department, and we can definitely get that over to you as soon as possible.
Yeah, I'll just pop that in the chat as well, but I will also include that in the follow-up email.
Great.
I think we've covered everything now.
Awesome.
Yeah, brilliant. So yeah, thanks very much, Maria. Really appreciate it, and lots of great knowledge. And I think that's a good reference, actually, the AirCheck Lab website. There's lots of good resources on there as well.
Great.
So
thanks so much, Simon.
Yeah, have a nice weekend, Maria.
You too.
Take care. Bye-bye.
Bye.
Yeah, thanks to Maria Sandoval from Trace Analytics, one of the sponsors of Food Safety Fridays and IFSQN. They've got another 3 webinars this year planned, so watch out for those. We've just updated the schedule on, well, we're in the middle of updating the schedule on the website. I think we've got 13 webinars added, so you can take a look at those and register, and we've got about another 15 or more to add, so plenty of webinars throughout 2023. We'll follow up with an email shortly to everybody registered here. That will include the recording, slides, certificate of attendance, and also those links that we've put in the chat. So thanks for your attendance today. Enjoy the rest of your day. Have a great weekend, and we'll see you on the next one. Thanks.